I'm a petroleum geologist and organic petrologist at OGS. My work and research has been focused on oil and gas, but also on carbon sequestration, carbon capture, and also critical mineral. I've been with OGS since 2018 and working with great team members here. It's a great team of geologists that we are working on different topics. Today, my topic is overview of the potential for selected minerals in Oklahoma. And the outline of this presentation is critical mineral potential in coals, utilizing the National Uranium Resource Evaluation or NURI database for our state, helium potential in Northwest Oklahoma, Cimarron County, and looking at some key formations there, the copper prospect in Black Mesa Mountains in northwestern Oklahoma, and critical minerals in basement mafic and ultramafic rocks and associated sediment in southern Oklahoma. Historically, our state has been producing lead, zinc, road material, but there are unexplored potential here, which I will try in this time frame to address in relation to critical mineral. For example, in Ottawa County, and the Miami Pitcher mine historically provided the lead, zinc, all the trajectories that were used in World War I. And some of the environmental issues that Jesse mentioned hampered further usage of resources there. But I will talk today about the minerals associated with coal deposit. This is in collaboration with our geologist, Brian Cardot, who retired from OGS. In this map, you see the commercial and non-commercial coal, and also a series of core coals and samples that we have, and they have been analyzed over the years. And some of the rankings have been determined, and work is in progress in relationship, understanding the stratigraphy, the distribution of critical minerals in coal, underclay, and bottom ash deposits. I will show you some cross sections from some of our key coals that have potential for critical minerals. These are some prominent shallow type of coal in our state. One of my tasks was quickly to evaluate what are the potential critical mineral that are associated. So I quickly sampled some of them, some of these coals, and send it to a spectral evaluation. So I can see utilizing a portable instrument, what are potential high critical mineral or elements present. And I saw high concentration of nickel and cobalt in many of these that was conducted by a spectral evaluation. There's a portable tool called Ore Expert and Ore Explore. And there's a presentation on our website if you would like to further evaluate that. One of my goals was to look at the coal, but also look at underclay. So this one is a hardened core in Nevada County. This one I analyzed the coal itself, but also we explored the possibility of critical mineral. And what we noticed immediately was presence of monazite, which is a lithium-rich rare earth type of mineral in this case, and it's present in underclay. So there is potential here to evaluate this further. We have other cores, and this one is a Harmon core, and this one, that's from southern part of Nevada County, and is under study as we speak. The only operational coal mine is Metropolis mine. Mineral core is present, and we have sampled these coals and also underclay, and conducted organic petrography to understand the maturity of this core and this coal and other coals. We want to see if there is any relationship between maturity of coal and the critical mineral content or not. And this is this is ongoing. Some of the analyses that have been done, this is on that mineral coal from Metropolis mine. You see presence of series of elements in this coal. And we are looking also at underclay that is for another presentation. We have also identified location of sites to evaluate the bottom ash in our state. And we are in plan of drilling some shallow cores and evaluating in the bottom ash. We think that there could be a high potential for critical mineral from bottom ash. Historically, the coals in Oklahoma were used for power plants, but not anymore. Most of it is right now imported. And we think there is an opportunity here. Then I studied the National Uranium Resource Evaluation data. These are sediments that were collected by USGS from major rivers, superficial kind of data. We don't have all the data in some of the counties in Panhandle and some other adjusted county, but there are considerable data for the rest of the counties. I plotted these data, and we see high concentration in different areas of Oklahoma, in Wichita Mountains in particular, in Wajita Mountains, in eastern Oklahoma, in Ozark Uplift and Cherokee Platform are noted, and also in Anadarko Shelf. So series of critical minerals and rare earth are associated here. Here is just zoom in area for Okmulgee County. And you see the presence of cobalt and other elements that are present highly here, just in the sediments that we examined. Another project that we are doing, this is in collaboration with Mike Smith and Christopher Smith, and we are looking at the helium content in Cimarron County, in Cimarron Arch. And we are looking at not only understanding the content of that, but also where is the source of the helium and what are the influencing factors that provide helium in certain strata. So we are looking at Keys formation here, but also we are trying to understand if there is sealing capacity associated with Atoko Shale and Chester formation. And mercury capillary pressure analysis shows that that Atoko Shale is a really good seal in this study. So far, the bottom shale, the bottom rock, the Chester formation also has good sealing capacity, but also we see that the Keys formation, which is the host for helium, the tighter rocks have considerable helium associated with them. This is the plot of helium data utilizing USGS data, but also utilizing three sites that were evaluated by Dr. Chris Smith and Christopher Smith advanced hydrocarbon, that we see here are the contour lines and the size of these bubbles noted as far as presence of helium. It's showing converted the value. We converted the value to more mole per microliter that we can see. So there is potential here. We think it extends to our neighbor Arkansas and Texas. This is, I think, has great potential, and it can extend down to Cherokee platform. It's ongoing research that we are doing. Another research, we are looking at Black Mesa Mountain in northwest Oklahoma. This is again between Oklahoma, Colorado, and New Mexico. We are looking at carbon capture potential in basalt there, but also we are looking at potential critical mineral. This is a work that was done by Robert Fay, Dr. Fay, who worked for many years at Oklahoma Geological Survey. I colored these that we can see there are sites here that show the presence of copper in the Shippen sandstone. It's Triassic in age, but there is copper, zinc, and series of other elements that are associated with that. Dr. Fay noted that the copper probably was carried under oxidizing condition and deposited under reducing condition. We wanted to see if we compare these, we saw that there is high concentration of silver, barium, copper, nickel, lead, strontium, titanium, and vanadium are associated with this. I'm just showing the Oklahoma side. So there is great potential here for further exploration in this site. Now we wanted to look at basement rocks and associated sediments. One of the earlier work done by some of the geologists in our state, particularly Roger Cooper, who did a semi-provenance study in Wichita Mountain in southwestern part of our state. And I will show you some of the Raggedy Mountain area that he did semi-provenance source rock. And then we look at the core in another area. This is the map, topo map that he used, and he looked at around the mouth of major river potentially and selected some samples, made thin sections, sent the samples for some analyses, and he saw some potential there. This was done in early 80s. We will look at some a core here, a dedicated core in Gabbros, in Wichita granite group. Now I'll show you an SCM, electron microprobe analysis of one of these samples that Cooper collected, and immediately what we noticed was high concentration of ilmenite, which is a titanium oxide in this sample. Furthermore, we wanted to look at the core itself. This was originally planned for an oil well, but they thought maybe it's this, they encountered an intrusion. They thought it's an intrusion, but in reality, there was 4,000 feet of gabbro core was recovered. The gabbro, the lower part of the gabbro is enriched in titanium, vanadium, and nickel. Based on the data we see, I think it has great potential for further exploration in Wichita Mountain. Ultramafic aspect of these rocks are really valuable for carbon capture because these are enriched in olivine, and olivine can react really fast with liquid high super pressured CO2, liquid CO2. So in summary, our state, we look at some of the basement rock, associated sediments, and we see potential for critical minerals and rare earth. We also look at coal under clay and we see great potential for there as well. And work is underway to examine the bottom ash. I think that has also great potential for exploration. We are also looking at helium potential in Cimarron and some associated county. This is ongoing work, and I think it would extend beyond our border. It's a great potential in our state. Thank you for your attention. Please send me or ask me questions. You can contact me. My email is shown below, and I'll be glad to answer any questions.